This is lesson 5 of topic 4. For this lesson, you're going to need a protractor and your patty paper that you used on lesson 4.3. So for the notes on 4.3, we did a patty paper exploration of vertical angles, and you will need that for this lesson today. So in this lesson, we're going to be able to use inductive reasoning and make conjectures in order to complete some proofs using deductive reasoning. And then we're going to review some concepts from topic 4. Let's see if I can go to the next page. Okay, so on 4.3, remember we did this patty paper exploration where we drew two intersecting lines which created two pairs of vertical angles. We measured those and found that they had equal measures, and so we learned that vertical angles are congruent. So what we're going to do here is we're going to fold some angle bisectors, and the first fold we're going to do is the angle bisector of angle AED. So remember, to do an angle bisector fold, you fold side on top of side, not point to point, side to side, and you want to go through point E with that fold. So I need to remember to always get your fold done correctly before you crease. And so when you open your crease, that fold line should create two congruent parts here. And for the vertical angle, since it's congruent, we should have congruent parts there as well. Now we're going to fold another angle bisector of AEB. So again, side on top of side. That fold should go through E, and it should also bisect the vertical angle as well. So I'm going to fold side on top of side, going through point E. If I can get it situated correctly. Alright, and there is that fold going right through E, bisecting both of those angles. So I'm going to use the straight edge of my protractor to kind of go over those crease lines to make it a little bit easier to see. It's hard for me to see my crease lines to go over them, but I'm going to do my best here. I believe it's right there. Didn't go through E very well. Well, it's not writing on there either. Well, I'm just going to make it a little bit darker, at least. For some reason my pen doesn't want to write on this right now. So, you can't really see that very well. I don't know why it's not writing on the patty paper right now. There we go. Now it wants to work. Alright, and so what we're going to do now is we're going to measure angle. Let's mark some things here. Put a point here and label that as F, and put a point on this bisector and label that G. And so we're going to measure the angle FEG. So that angle bisector we created here, going through E and out to this angle bisector here. Okay, so remember to use your protractor. You're going to line up with your vertex of the angle, which is E. I want one side of that to go through 0 on my protractor, so I've lined up against EG here. And I want to see where my other line goes through on the other side. And it looks like it goes right through 90 degrees. So it looks like FEG is a 90-degree angle, and I can mark that on my figure with that right angle symbol. So we're going to write a conjecture for number 1 on our notes based on that patty paper exploration. And we are going to, it says write a conjecture about the angle bisectors of non-vertical angles. So this angle and this angle are not vertical to each other. They're adjacent to each other. So the angle bisectors of non-vertical angles, you can either say intersect to create 90-degree angles, or you can say they're perpendicular, because that means exactly the same thing. So This, you can see it on your notes as well. This is an angle bisector of AED and BEG. And this is an angle bisector of angles AEB and DEG. And when we measured angle FEG, we found that to be 90 degrees. And so these angle bisectors are perpendicular to each other. Let's look at a proof of that conjecture. So remember, once you have a conjecture, we just made a conjecture based on our observations. That's using inductive reasoning because we're just using specific examples. But once we prove it, we're using deductive reasoning, and it becomes a theorem at that point. So I'm going to do this actually on the notes. I think that'll be easier for you to see here. But we're using these answer choices. We are given that angle 1 and 2 have equal measures, and that's because, remember, that fold was an angle bisector. And we're given 3 and 4 are equal measures, and again, it's because that dotted line was that fold of the angle bisector. We're trying to prove that the measure of angle FEG is a 90-degree angle. That was our conjecture that we made. So remember, when we started proofs, I told you that typically the given is at the beginning of a proof, but in this proof it is not. We have 4 statements before we ever get to the given information. So the first 4 are given to us, but let's make sure that we understand what they are saying. So number 1 is telling us that angle DEC and DEA are supplementary to each other, and the reason for that is the linear pair theorem. So remember, by definition, a linear pair are adjacent angles that make a straight angle together, and those do make that straight angle AEC together. So they are a linear pair, and the theorem says that means they are supplementary. Now, by definition of supplementary angles, we know that means their measures have to add up to be 180 degrees. So number 2 says the measure of angle DEC plus the measure of angle DEA equals 180 degrees. You will always have these little m's for measures when you're talking about numbers. So in number 1, we didn't have them because we were talking about the angles themselves, not their measures. So now we're going to use the angle addition postulate. Anytime you see addition postulate, I want you to think parts add to the whole. And in this case, we're looking at angle parts adding to the whole angle. And so it has 2 different pairs that we're looking at. We know that these parts, 1 and 2, together make this whole angle DEC. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle DEC. 3 and 4 are the parts that make up angle DEA. So we would say the measure of angle 3 plus the measure of angle 4 equals the measure of angle DEA. And again, that's using the angle addition postulate. Now we're going to use some substitution. So since we know the measure of angle DEC plus the measure of angle DEA equals 180 degrees, we're going to replace the measure of angle DEC with what it's equal to, which is the measure of angle 1 plus the measure of angle 2. So this was the measure of angle DEC. We're going to replace the measure of angle DEA with what it was equal to, which was the measure of angle 3 plus the measure of angle 4. So that's where this came from right here. That was the measure of angle DEA. Still adding to equal 180 degrees as the equation states in number 2. And again, that's using substitution. So we don't get to our 2 given statements, we have 2 of them, until we get to number 5. Notice number 6 is the measure of angle 3 equals the measure of angle 4. So when it's your given statement, your reason is given. The other given statement is going to go in number 5. So we're going to write our statement is the measure of angle 1 equals the measure of angle 2. And again, that is simply given. So I always say these would be bless your heart moments. If you ever miss the reason for a given statement, that would be extremely sad. Those are supposed to be the easy parts. All right, so then let's look what's going on here. The flowchart has all these arrows, and when you do your own, you won't draw these arrows, but it's kind of giving you a hint. To get to number 7, you have to use 4, 5, and 6 together to get down here. So I want you to notice that we have in number 4 the measure of angle 1 plus the measure of angle 2. Well, since we know the measure of angle 1 is equal to the measure of angle 2, we're simply going to replace the measure of angle 1 with the measure of angle 2. And then in the other part of the equation, the measure of angle 3 plus the measure of angle 4, since we know they're equal, we're replacing the measure of angle 4 with the measure of angle 3. So when you replace something with something that's equal to it, what is that reason going to be? I hope that you're recognizing that as the substitution property at this point. Remember, do not use SUB as shorthand for substitution because then that looks like subtraction as well. So here we just combined like terms. They didn't give us another reason here, but that's all that's happening from here to here. We had the measure of angle 2 plus the measure of angle 2 is the same thing as 2 measures of angle 2. And the measure of angle 3 plus the measure of angle 3 is the same thing as 2 measures of angle 3. So we're really just combining like terms there. So notice from here to here, we are saying that 1 measure of angle 2 plus 1 measure of angle 3 equals 90 degrees. So what did we do to get rid of those 2's and to make that 180 become 90? Well, all we did was we divided everything by 2. So the reason we got to this statement is using the division property of equality. Remember, if you divide by the same thing on both sides of an equation, you're keeping it equal. All right, so then we say the angle addition postulate as our reason here. And remember again, I want you to always think parts add to the whole. Well, how is that going to be helpful? We're talking about the measures of angle 2 and 3 here. We're wanting to get to the measure of angle FEG equals 90 degrees. So let's look at our drawing here. Here's FEG. Notice it takes angles 2 and 3 together to make angle FEG. So parts adding to the whole, we're wanting to put that it takes angles 2 and 3 together to make the whole angle FEG. So our statement on number 9 should be the measure of angle 2 plus the measure of angle 3 equals the whole thing, the measure of angle FEG. These parts add to get that whole. So now, remember, this is another bless your heart moment if you miss this last statement, because your last statement of a proof should always be what you're trying to prove. So we know that our last statement should be the measure of angle FEG equals 90 degrees. Now the reason's not that easy. We never write prove as our reason, okay? Even though we write given as the reason for the given statements, you don't write prove for what you're trying to prove. There has to be a reason that you can get down here. So look above, we know that the measure of angle 2 plus the measure of angle 3 equals the measure of angle FEG. How is that going to get me to 90 degrees? Well, in number 8, you can see the arrows here are saying we need 8 and 9 to make this statement. In number 8, we said the measure of angle 2 plus the measure of angle 3 is 90 degrees. Well, if it's equal to 90 degrees and it's equal to the measure of angle FEG, that means the measure of angle FEG must equal 90 degrees. Now, some would say, well, that's the transitive property, and I agree, but a lot of times transitive and substitution are interchangeable. So what's happening here is we are replacing the measure of angle 2 plus 3 with something that it's equal to, which is 90 degrees. So we're replacing this with what's equal to it, which is 90 degrees. So the reason for that is substitution. If transitive property was an option, then that would be perfectly fine to use in this case as well. So we just proved our conjecture on number 1, which means, again, now that is a theorem. We can say that that is absolutely true beyond a doubt. We proved it true in every case. All right, so that's the end of your notes, but not the end of the lesson. The next video, we will review some things that we learned in topic 4. We will complete topic 5 before our next test.